We'll get started here. It's there's donuts in the back. Help yourself. And my name is Brad from Rockwell Engineering. We represent Vogelsang pumps as well as Vaughn chopper pumps and some other lines. I know I've met some of you through the years on other equipments. So, but today we're going to talk about Vogelsang. They have the polymer pumps out right here next to the dewatering building, as well as the transfer pumps that go to the centrifuge. If feel free to ask any questions here as we go along. Now, Vogelsang's a German company. They have an office and manufacturing plant in Ohio, and they make rotary lobe pumps. And I know you're pretty familiar with like progressive cavity pumps, whether it be Netsch or Moino, people like that. This is the same concept, a PD type pump with a lobe that does the instead of a long rotor stator like a Moino pump has. These are more compact, and we'll walk outside. Actually, you can see them. The front page there basically shows the lobes themselves. The pump opens right up. Instead of a long rotor stator with the auger of a rotor stator design, you can see the lobes there on the front page there. That's what makes the positive pressure and flow rate for the pumps. There's a casing that opens up there. You're looking at the two lobes. You open up the front plate, opens right up into the rotary lobes, and those slide right out the shaft, and that's the rotor compound, you know, the comparable rotor that you would have on a Moino Netsch type pump. So a lot more compact, a lot smaller. That's also their grinder, which is similar to the Muffin Monster type units that you guys are used to as well. The flow is these can go either direction, just like the PC pumps. Flow wise, you can reverse them so they can pump left or right as it comes in out of the suction and discharge flanges there. And then there's a mechanical seal behind the lobes, and then the bearing housing with all the bearings. They're a dual shaft with the dual lobes there. They don't have any pulsation, which from an operation standpoint, they're nice and smooth. They have a nice laminar, no pulsations as they pump, so whether it be the polymer or the sludge, it'll be a nice smooth flow rate going through there without the pulsations of opening and closing like some of the other pumps do for PD pumps. So the concept's pretty simple here, and the pumps themselves, when we walk out there, you can see how compact they are. We don't have any pumps that are open, but that's the basic concept of how they work from a pumping standpoint. So these are low pressure somewhat on the polymer. They're just transferring in. Same with the transfer pumps for the sludge to the centrifuges. They're basically upstairs elevated there, so it's not that far to run, but they are consistent on the flow rates. If they're 150 gallons to 200 gallons, these pumps run at a fairly slow speed. From a wear and tear standpoint, you don't wear out the rubber. These are unit and rotary lobes themselves. If I can borrow your, you're on the right page there. I was going to show that they have a twisted. It's on page. I guess it would be 6 here. They don't actually have a page number on them. It's behind the big. This is the opening of the pump itself. And then the next page is just going to show on the no pulsations. They have an angle to the lobes that creates more of an auger effect as it makes it nice and smooth as the sludge comes in, or the polymer, and that's where you don't have any of the pulsation going on. It also makes it a little bit more efficient, so that they have an angle of being able to move the flow more efficiently versus some of the other people that will be straight, as they call them, and they're not as efficient as the Vogelsangs. They're made of Buna N, and you can make them out of any material that you want, from EPDM, Viton, anything you want. Basically, there's other people, we make them out of stainless steel if you want, metal, but being rubber, they're a lot more forgiving. If you get a rag in there, if you get a nuts, bolts, or whatever, they'll chew up a little bit on the rubber, but you're going to be able to keep on going without plugging or stopping, backing up the pump.
Okay, good. We're probably going to be running 1.92% solids, and you pretty much had answered the question that I had. Site specific, what are these flow rated at? GPM? What we have on site?
Yeah, the ones on the sludge to the centrifuges are on a VFD, so they will vary. They're from 100 to 400 gallons, I think, is the overall range on those. Those are a little bit bigger, and then The polymer pumps are 50 gallons up to 200 gallons from a flow standpoint.
Okay.
And the speed is relatively around a 200 to 250 RPM. Slower is better, lasts longer. There is a pinch point, you know, on the rubber, on the lobe itself, because it's rubber. That's where you create your pressure, just like on a, you know, progressive cavity type pump. These pumps can run dry, by the way, without, you know, the other pumps can't. These can run dry. It's not recommended because you will build up heat on the lobes themselves over time. But they can handle, you know, very viscous type solids and sludges where you can get very, very thick, like peanut butter up to a real thick, like peanut butter type material.
Wow.
They do create suction lift, you know, because they are a positive displacement type pumps, so they can pull the liquid
You have
in.
a vacuum.
Yeah, right. Create a vacuum and then pump it out.
These aren't work related, sorry about that.
So since maintenance, you know, is not, you guys don't do any much maintenance on them, right? So there's not a whole lot to talk about except for the lobes themselves pull right off when you open up the casing. In case we'll go out there and I can show you that, but maintenance-wise, they're very easy to work on. They have a mechanical seal, just so you know, with the oil bath lubrication. That's where they can run dry. They're self-cooling and self-lubricating on the oil. The mechanical seal is behind the lobes there, going into the, it's separated there in the bearing housing to the pump casing itself.
Just using this for an example here, I have to assume that one side's suction, one side's discharge. Is there an inspection plane in here that we could pop open and take a look at it if there was a problem?
Well, they're showing that these flanges actually bolt right up to the casing, so there's different flanges. You have what we call like a gooseneck, which is down here, so the flow always is in the casing, but these open right up. They don't have an inspection port like some other pumps where you can take a bolt off and open it up, because the flanges themselves will pull right off.
Okay.
And open up into the pump on either side. The goosenecks, because of the angle, the liquid would be down low in the casing itself, so they're somewhat already primed, always having liquid in the casing. They do make flanges to go straight, but the engineer wanted where the liquid is, this is more the standard design where you have some angle so the liquid's down low into the casing. But that is the inspection port on that, it's just opening them up. The inspection port also is just the whole casing here.
Pull the whole front off.
Yeah, you know, so the 4 bolts here, that's what it shows right here, would open up the whole casing so you're right inside the pump itself. So they don't make like a little mini port or anything like that because it's so easy to just open it up anyway. As time goes along, this casing itself, there's an adjustment on here. Again, it would be more of a maintenance item, but the casing, you can compress it down to create more of, as it wear with the grit and sand, you'll get some wear on the rubber lobes. Some clearance will go in there, so you can compress the casing, close it down the tolerance, so then you get a better, you know, your pressure will tend to drop off a little bit. By locking it down, closing it down, you get that compression again back in the lobes, and then you get more pressure out of it. You'll get a little slip as it wears.
Natural wear and tear you're making up for the tighter tolerances.
Right.
So, what you've seen on the discharge side, how high would we expect the pressure to be? Is it under 30 psi?
I think it's under 40 is what they were rated for. I'm sure they're a little bit oversized. I haven't seen on the pressure when we ran them last week that high of pressures.
Okay.
Each one of these, just like a stage and a moino, you know how it goes up to 70 pounds pressure. That's the max pressure on these as well until we go to the next size for. You get bigger lobes, next size bigger, can create more pressure.
Did we put high pressure shut off or cut off on those things?
They have downstream, they have overloads, right? So you don't deadhead against the
Closed valve or something?
Yeah, something like that. Because that will, just like any other pump on these, it'll build up the
Break some
pressure,
lines.
right? And they'll create heat inside there, just like running it dry. If you're deadheading, it's trying to push liquid and it's up against a closed valve, then you're creating heat as well. And so there are some downstream overloads to let, I guess, operations or go to a control panel at least to let you know that you have exceeded the pressure.
On the maintenance side of it, basically looks like whatever type of Allen, nut holding it. Is it that simple where you're just gonna go and relieve the torque and pull the for a replacement?
Yeah.
Not
Yeah,
that bolted, huh?
it's 4
Wow.
bolts to open up the casing. Same with the discharge flanges, they're all just bolted suction and discharge to open it up. And we'll walk out there and we can take a look and I can show you that. But it is that easy. There's not, that's why the inspection ports, they don't need one, because you can take 4 bolts and open up the whole pump. Now those are wear plates as well, that front casing that we're talking about here, the bolts, that's a wear plate on the suction, as well as they have one in the back for the grit and the sand that we see for wastewater. And over, it's a hardened tool steel 65 Rockwell minimum, so we're as hard as we can be without being brittle, to hold up against the sand and grit. Any questions? Besides that, it's pretty straightforward. There's not a whole lot there. It's pretty simple. Size-wise, they aren't huge, even though these are fairly good-sized motors. They're belt drives. I mean, they come in direct drives. You have belt drives, which is a little bit more standard, where you have a standard motor slowed down by a belt drive system, and then on sludge transfers, you have DFDs there anyway, so you can speed them up or slow them down. The polymer pumps are direct in one speed on those, and they're set for a flow rate, and then they have bypass, I guess, on your valving, so that if you have too much polymer going one direction, you can return it back to the tank.
Yeah, your footprint is considerably smaller than what we're used to seeing in a lane.
Sure, right. From a maintenance standpoint too, you usually have to have a lot of clearance. If you're going to open up and take out the rotor stator, you need another 6 feet or whatever to be able to clear your piping, pull out the rotor stator to work on them. These are, again, the piping can remain in place, and then you open up that front casing, the front plate there into the pump casing.
Yeah. As far as operations, that's half our battle of going, and it's quite a bit of man hours involved, when we're dealing with the other, and having maintenance go and just open them up or replace or have them rebuilt,
Right.
It look pretty promising.
Right, half the time, it's just setting up and taking all the piping apart is half the work before you get into the pump itself. On the back, just so that's a little bit more, just extra information, but the grinders you guys have at some of the other plants, they have a rock trap at the bottom, but those are a Vogelsang grinder that usually goes in front of any pumping system, and they grind up, well, first coming in, there's a rock trap, so all the rocks, metal drop down below, and then going through the grinder itself. And
We used to have one here.
yeah, a couple, one or two anyway.
Yeah, we used to have one for the manure project over here.
Oh, right, manure, right. Is that going still, or no? Again, that's more of a maintenance item. I think once they were installed, pretty much we were dealing with maintenance on the upkeep and.
Well, actually, we had to clean them out 2 or 3 times a day.
Oh, did you? On operations wise?
Yeah, there was so much twine and baling wire in there from the tankers. It would pass through the rock box and everything, and then we'd get into the grinder before it went in, and it just bind up in there and just make big balls. So we'd have to pull it up apart 2 or 3 times a day and clean it out.
Okay.
Didn't
They
take
end up-
long. It was not too labor intensive. It was just the material that you were dealing with that was the hindrance.
Yeah. You don't do manure here at all?
Not anymore. Thank goodness.
Yeah. Well, if you want, we can go out and take a look at the pumps. Maybe you might have a couple of questions there, but we can go through them. You can see the size and a little bit more of the features when you got your hands on the equipment itself.
Definitely. All right, thanks.